Unit 2, this is lesson 2.6, part 2, so the second part of chain rule. So with that, we've kind of already understand the process in terms of we want to take the derivative of the outside and the derivative of the inside. Okay. In the definition, if we just go back just to refresh since it's Monday here, where's it at here? Okay, so right here is the definition. So you have f of g of x, which means you have something inside. The g is the inside. And so they tell you to take the derivative of the outside. That's what this right here is. That's the outside. And the derivative of the inside. They multiply them by each other. Okay, that's the chain rule. Okay. All right. Okay, so with this one, we're going to take the derivative of the outside. To take the derivative of the outside, the first thing we're going to do is we're going to drop the 6. So we're going to get 6 right here. Then we're going to get 2t minus 1 all over t plus 2 to the 5th. That's done for the outside. Okay, when I do these problems, just to be organized, I like to just leave that here, and then over on the right, kind of do my inside work, because then my inside is where I'm going to have to do my work, so I have to use the quotient rule. Okay, so again, low d high minus high d low, all over low squared. Okay, so with that said, low t plus 2, derivative of high, 2, minus high, 2t minus 1, derivative of low is 1. So you don't have to write that, but I will for now. Low squared is t plus 2 squared. Okay. Now from here, we just want to simplify the top. Leave the bottom, don't boil out or anything. Top's going to be 2t plus 4 minus 2t minus a minus the plus 1. My t's cancel. I'm left with 5 on top. So that's what we're going to write right here. And then we can also put the 6 in it. Okay, we can put the 6 in it, and I'll show you one other thing we can do to make it all 1. So if you have something to the 5th and you do it to the fraction, what's it hit? The top and the bottom. So we can also write this like this. So notice that the bottoms are both t plus 2 still. So what would be a t plus 2 squared times a t plus 2 to the 5th? Not 10th. 7th, you add exponents, remember? So that's okay. The 30 is from the 5 times the 6. Right there, yep. Okay, so I can actually put this all together, and then if I lose you here, let me know. The 30 is just going to slide right into the top. 2t minus 1 to the 5th. The bottom, like we just said, was t plus 2 to the 7th. That's your S prime. That's as simple as it gets. Okay, don't forget, this is still the derivative. This is still technically the equation of the tangent slope. Okay, I know it's more difficult. Okay, but that's kind of where we're going here. Okay. Any questions? Got anything, Rachel? Just looking through it. Okay, next one. Okay, 2t. Wait, we just did this one, didn't we? Oh, I think I did it for 2 pages. I thought it was going to be longer. So that's good. Okay, example 6. Find the derivative of the function x squared plus 1 cubed times 2 minus 3x to the 4th. So this is kind of 2 things in one. Okay, I have a what? Product of two chains. Does that make sense? I have a product rule where I'm going to do chain rule twice. Okay, but we're still going to just do your product rule, and then when you get to the point where you're taking the derivative of the first, you do the chain rule. Okay, so we're going to do first times derivative of the second. So derivative of the second. Now, if you want to do use, you're welcome to. Okay, I think in my notes I mostly don't. Okay, so I get 4 times 2 minus 3x cubed. So I dropped the 4 for the second. Change to 3. What's the derivative of the inside? -3, good. Add second derivative of the first. Derivative of the first, drop the 3. X squared plus 1 squared. Derivative of the inside now is 2x. Okay, now I'm going to put everything together that I can. So I can put this to be a -12 times x squared plus 1 cubed times 2 minus 3x cubed. That's my first piece. Simplify as much as I can. My second piece will be plus 6x, 2 minus 3x to the fourth, times x squared plus 1 squared. That's it. That's f of prime. If you can't read anything up there, let me know. It is a -12 there with my pen in the way. Okay, so I guess we're not into insane stuff yet. Hopefully you don't think so. Okay, nothing? We're still fine? Okay, so example 7. Got 2 more here. All right, if h is differentiable to the function, find the derivatives of the following functions. Okay, so it's just making you practice the rules. So for a, we want f prime. So understand that this right here is still the inside. That's still the inside. H of x is my inside. So they're just making you write the chain rule out. Okay? So when you take the derivative of that, what are you going to get? You're going to get 3 times h of x squared, then what? Right, times h prime of x, because that would be your derivative of h of x. That's all they want you to write. Don't overthink it. They're just making you restate the chain rule. Okay, so take a second. Try B. Try B. I'll pause the video here. All right, so with this one, what's different is you essentially have to do the product rule, okay, because you have h of x cubed. So what we're going to do is we're going to go ahead and go, we want to take h prime of x cubed, and then we want to take the derivative of x cubed. It's not really the product rule, I guess. It's just the opposite. 3x squared. Because we don't know what the outside is, essentially. Same as the other one, except for, see, this is a little different. So we're taking the derivative of this whole thing, so we're calling that the h prime. So this one doesn't have an x cubed. It's the only difference. I mean, it's a little bit different. And the derivative of the inside would be 3x squared multiplied. Okay, and you can write that with the 3x squared in front, like so. Okay, all right, last one here. All right. Find y prime of this one. I'm going to kind of challenge a little bit, just see if you can even get where you could start and see where you can go from there. It's going to be a chain and a chain here. That's where it gets kind of messy. So first thing is I'd write it like this. I would write, okay, x plus, and then I would put this right here, like that. So you have 1/2 to 1/2. We'll worry about the negative exponents last, but we're going to drop the 1/2 still. No big deal. 1/2. We'll just put that to the negative 1/2 for a second. So by chain rule, what should we do now? What's this next part? We did the outside. Got to do by the derivative of the inside. In the inside, do you see there's another chain piece in there? You have this chain piece in there now too. So you're going to go times. It's still times. Derivative of that is 1. Okay, derivative of this is going to be 1/2. We drop the half. X squared plus 1 to the negative 1/2. And what's the derivative of the inside of that? 2x. Good. So there it is. Okay, now we're going to work on moving our exponents around and whatnot. Okay, since this is all to the negative, I'm going to move the whole thing down. Derivative inside of here. Okay, so we have that moved down. Oh, sorry, this has brackets on it here. Okay, and then it's going to be times the second piece, which we've already got. I'm just going to move this negative exponent down. So it's going to be 1 plus 1 over 2 x squared plus 1 to the 1/2. And where's the 2x go? On top. Good. I'm just going to set it right there for right now. Here, it's just on top. Like I'm just waiting to put it on top. It's a multiplication, yeah, and it's not going to hit this 1 here. So it's really just on top. Maybe we can just write on top. Okay. Now, which part? That's what we're doing next. Yeah, we're going to take this guy and it's going to hit both. Okay, it's going to distribute it both. But what you need to understand, guys, what is this? What is this? It's this. That's all it is. It's that original, right? Because remember when we took the square root, when we did x to the 1/2, remember the root x? That always gave us 1 over 2 root x, right? So it's just 1 over 2 of what we had. Okay, so I'm going to put these back into the radicals things. So the radicals back in. So 2 of this. Okay, so that's just good. That's what we're going to be distributing. That's what we're going to distribute and not worry about. Right, that's why we're kind of doing it. Okay, so are you guys okay with this right here multiplying to that? It's just this. Can I just leave that there? So I don't have to rewrite it. So what we did was we just multiplied the little 1. That got the first piece. That's our first piece right there. Now I want to do plus. Okay, and the second piece, let me see here. Find my notes. Okay, so we should get, well, I did write them here. I'm losing my spot here. Just save this. I'm going to go to the next page real quick here. So this is where I'm at. Oh, okay. So let's go back a page. So what I did real quick is I got these to have a common denominator. So I made the 1 this. So watch, this is what it'll look like. That's what it looks like after you get a common denominator. I combined the 1 to the 1 on the right, and that's what it turned out to be after you do a common denominator. It just helps with simplification. Okay, so that's why we're doing it. Yeah. If you're wondering where the 2's went, the 2's went away because 2 and 2. If you're wondering where the 2's went, they just canceled. That's why they're gone. Okay, so now actually let's distribute it like you were saying. So after we do this, all right. So that's just 1 times that. It's just going to give me that. These? No, because of the plus. Because the plus, we can't cancel it, right? Yeah, if they're multiplied, we could. Okay? So that's just what's on top. My bottom, I'm just going to leave it like this just because I think it's easier. Because you can't do anything with it. You're just going to leave it like that. You can't cancel because they're not exactly the same inside. Because this is already inside of something, so these two just can't pull out to each other. Okay, so just leave it just like that, and that's fine for your f prime. Okay, and that's it. That was kind of the crazy one, but